Hey, we've got two things taken care of already. Um, Gavin, I remember again us chatting years ago about you remotely participating in meetings,
Yeah,
and this all just seems sort of far-fetched and futuristic. And now it's like it's the only way we can do things is to
exactly.
have people join in by Zoom. I really do thank you for taking some time to join with us. We do know that the standards that we have for groundwater are going to be important, and the PFAS issue cuts across a lot of different communities in the state. I do appreciate you coming, and you're also part of the Science Policy Fellows. And I think that you're going to be joining the group on Wednesday. Does that sound right?
Correct. Yep.
Great. So we'll actually get to see you again on the big main stage.
Yeah.
Um, so Gavin is going to be sharing some of the work that he's been doing in the Department of Health Services. I will turn the microphone over to you.
Yeah. Well, good afternoon, everybody. Like Eric said, my name is Gavin Daynard, and I am a postdoctoral fellow with the Department of Health Services. And first, I just want to thank everybody for taking the time to come and listen to my talk. I know we're right after lunch, so I hope everybody's getting fed as you listen. And today I'm going to talk about the groundwater standards process and then go a little bit deeper into the groundwater standard recommendations for PFAS, especially in cycle 11. So first off, I just want to say, kind of talk a little bit about the process that Wisconsin goes through to make these recommended groundwater standards. And to do this, over 2/3 of Wisconsin residents actually use groundwater, especially for our drinking water. And the goal of Wisconsin and the Department of Health Services here is to develop groundwater standards that protect public health. And so the process for developing these groundwater standards is actually specified in state statute. So big picture, agencies like the Department of Natural Resources or DNR or DACAP will actually identify substances that are found in groundwater or may be found in groundwater. From that, what they do is the DNR will then wrap up all of these substances, send them to the Department of Health Services or DHS, and then ask us to review these substances. From there, DHS will use the scientific literature that is out there to develop recommended groundwater standards. And then we send them back to the DNR for them to propose and create these rules. And now, since a lot of the work that I did actually focus in on developing these recommended groundwater standards, let's go into a little bit deeper about that. So DHS follows a 4-step process to develop the recommended groundwater standards. First, we gather the relevant scientific information out there. Excuse me. And what I want to note is that DHS does not actually do any of these experiments ourselves. These are experiments that are done already and they're in the scientific literature, and we are just doing a giant literature review of that. And so with that, we then are able to find toxicity values that will help us then select appropriate standards. After we've selected the appropriate standards and developed them, we then document our findings and then further share our recommendations, sending them either back to DNR as well as with the general public. And Wisconsin's groundwater standards have 2 parts. We have an enforcement standard, or an ES, and we have a preventative action limit, or a PAL. The enforcement standard is established from health information. And this and the enforcement standard can be based on toxicology values that can come from a variety of different things. They can be based on a federal number that already exists out there. They can also be based on previously made state drinking water standards. They can be based on an EPA value that exists. They can be based on technical information, and by technical information, I'm talking about the literature review that we do, and some of these scientific papers that exist out there. And then they can also be based on cancer risk. To create these values, what we do is from when you're going through the literature and you're going through all these values, you then come across different toxicity values that I'll kind of get into a little bit more deeper later on of how we actually calculate one of those. And so you take a toxicity value and you divide it by uncertainty factors that get you to an acceptable daily intake to protect you for public health. And the uncertainty factors that I'm talking about is you can have differences between species. So if you're looking at an animal, a rat study, changing it from rats to humans, you have an uncertainty factor. There's an uncertainty factor added for differences among people. You can add uncertainty factors for study limitations, as well as for the available data that is out there. And so when you get this acceptable daily intake, you then plug it into an equation that is actually specified in state statute, where you take the acceptable daily intake times a body weight times a relative source contribution divided by the amount of water that is consumed in a day. And that's what we use to actually set or create our enforcement standards. And as I've mentioned, there was two parts to the standards. The first part, the enforcement standard. The second part, the preventative action limit, or the PAL. And this is actually set at a percentage of the enforcement standard. It can be set at 10% if the substance is known to cause carcinogenic or cancer effects, cause mutagenetic or damage to your DNA, teratogenetic or damaged or developmental problems, or interactive effects, meaning they have similar effects to other substances and can have synergistic or additive effects of another chemical. And so then if it's one of these four, then we are able to set the PAL, or the preventative action limit, at 10% of the enforcement standard. For all other substances, ones that are not mutagenetic, teratogenetic, interactive, cancer causing, we set this PAL at 20%. And so let's get into a little bit more detail of kind of like the types of studies that we may be looking at. And so most of these human health standards are based on toxicology studies that are conducted in research animals. For instance, what you'll have is usually you can have an animal like a rat or a mouse that is dosed to different concentrations of that chemical. And then what you do is you look at different health outcomes. They can be developmental, blood-related, antibodies, cancerous, etc. There's a lot of different health outcomes that we can look at. And these experiments, these animal experiments, are well known as dose-response experiments. And these dose-response experiments are used to figure out how much of a chemical is then needed to cause an effect. And so what I mean by that is a normal graph that you would see, you're going to have increasing dose on the bottom. So as you go from left to right here, you're seeing an increase in the dose. And then on the y-axis, you're going to have the response. And a normal dose response curve will kind of follow a similarity of this. As you increase the dose, you're seeing more and more of that response. And when you're looking at these two, most of these effects that we're going to see, they're going to have a threshold. And there's some level that is below which these effects are not expected to occur. And that's what's known as a NOEL, or a no observable adverse effect level. This is the concentration that is the highest tested dose that you do not see a response. The second thing that you're looking for is a low L, and the low L is a lowest observable adverse effect level. And this is the lowest tested dose with a response. And so what's important to note here is that most of these health standards are based on toxicology studies that are conducted in research animals. And that links back to some of those uncertainty factors we had talked about. And then two, toxicology studies that are called dose responses, that's the studies we're talking about here, these are used to figure out how much of a chemical is then needed to cause a response, cause an effect that is seen. So let's get into now a little bit about the Wisconsin's recommended groundwater standards, particularly for PFAS that were involved in cycle 10 and 11. So in March 2018, the DNR requested standards for both PFOA and PFAS. These are two PFAS that, and then some other substances as well. In June of 2019, DHS then recommended groundwater standards for both of these two substances, which we'll get into a little bit more later. And then the DNR started working on adopting these groundwater standards. In the meantime, in April of 2019, the DNR actually requested standards for 34 more PFAS. So they, in part of cycle 11 then, they decided they wanted us to look at more individual PFAS. And then as of November 2020, so very recently, we actually recommended groundwater standards for 16 of these PFAS and passed them back to the DNR for them to start working on adopting those standards as well. So part of this cycle 11 that we're talking about, DHS reviewed 34 individual PFAS. And these were chemicals that have either been found in the groundwater or likely to be found in our groundwater. And I've talked a lot about the process of how these groundwater standards are made so far. And we will get into more particulars of cycle 11, but first, let's talk about PFAS. So PFAS are per and polyfluoroalkyl substances, and these are a set of family of man-made chemicals. And there's approximately, more than 5,000 of these different PFAS that exist out there in the world, and that number is continuously growing day after day. I think I heard a more recent number that's maybe above 9,000. This number is constantly increasing. And part of the reason that it's we have so many different species or different PFAS out there is because they can have a couple different aspects. They can have different carbon chain lengths or different size of them. So PFDA is a 10 carbon chain length PFAS. And then on the end of it, you have a functional group. And this functional group can differ based on a different PFAS. So this is a very specific one that's 10 carbon chain lengths with this unique functional group. But just to give you a little variation, they can be a lot shorter, like PFBS. This is a 4 carbon chain length with a completely different functional group that is attached on. So you can see how very fast with different functional groups, different chain lengths, where the functional group is located, you can get to very high numbers of these PFAS in the environment and in the world. And it's important to note that these PFAS are very persistent in the environment and in the human body. So they can last both in the environment and the body for very long periods of time. And they've actually been labeled as forever chemicals. And on top of that is most people have some PFAS in their body. And we know that they exist everywhere. We know that they're kind of ubiquitous in the environment, and a lot of us have some sort of these PFAS in our body. But why do we care, right? So do they cause these health effects? And so what we know is that these PFAS actually can cause some negative health effects in people. And in particular, high levels of PFAS have been shown to increase cholesterol, reduce antibody response, and decrease fertility in women. PFAS have also been shown that high levels may also increase the risk of thyroid disease, testicular cancer, kidney cancer, etc. And it's important to note, though, when we're talking about these different health impacts, that each of these individual PFAS are showing us different health effects and potentially at different concentrations as well. And so now that we know there's PFAS everywhere in the environment, they have the potential to cause some negative health impacts, we might then kind of wonder, how are we commonly being exposed to PFAS? So we can be exposed to PFAS from food, as well as food packaging. We can be exposed through household products like stain removers, etc. But the one I want to talk to everybody about today is you can be exposed to PFAS from drinking water, which is why we set these groundwater standards for and with drinking water in mind. And as I've hinted towards, and as I've kind of showed, not all PFAS are the same. We look, they have different chain links, they can have different functional groups, they can have different amounts of time that can exist in your body, different amounts of time that they can exist in the environment. And maybe more importantly, they can have different health effects, especially at different concentrations. So one that might show a health effect at very low concentrations, we might not see an impact of a different PFAS until it gets to 1,000 to 2,000 times greater than that original PFAS. So each of these PFAS tend to show different health impacts at different concentrations. And so because of all these reasons and more, DHS chose to look at these chemicals first as an individual chemicals and not group them all together as a class of chemicals. And so again, part of cycle 11, DHS reviewed 34 individual PFAS. And after reviewing it, DHS then, we recommended individual standards for 12 different PFAS in cycle 11. And all of these PFAS recommendations were actually based on technical information, or they were based on information that came from the scientific literature that is out there. And without kind of walking through each individual kind of process, because we don't have enough time to go through all that, what I'm going to give is just kind of a big overview of kind of the exact process when you're looking at the different literature that's out there. So many of these PFAS recommendations are actually based on reproductive studies that are in rats or mice, etc. And you're going to have an experiment that's going to look very similar to this, where the rats were exposed to different concentrations of a PFAS, ranging anywhere from, let's say, 0 to 400 micrograms per kilogram per day. Then what they do is then they would look at different endpoints. So when you're looking at a graph like this, you might say, okay, they looked at reproduction as an endpoint, and they started to see impacts or effects of that PFAS starting at 50 micrograms per kilogram per day. Another endpoint they might look at would have been offspring survival. Again, similar from before, they're starting to see effects then about 50 micrograms per kilogram per day. But then they might look at a more sensitive endpoint like bone formation, where they're seeing these effects happen at even lower concentrations of that 5, as well as some of the other ones such as sexual development that they're also seeing potentially at lower concentrations. And so when you're looking at data like this, if you were to only look at the reproduction and offspring survival, you might come up with a NOEL of 15 and a LOEL of 50 from what we had talked about before. However, when you're looking at the entire experiment, you're going to say there is no NOEL because we actually see some impacts at the lowest concentration. So from a study like this, you would only be able to get a LOEL, thus labeled here with the stars. And so what we would do is that concentration right there, the 5 micrograms per kilogram per day, that becomes our toxicity value. That's the lowest concentration that we could find from an experiment like this. And so what we then do is we go back to our formulations that are specified in state statute, and we're able to plug in our data. So for instance, in this one, you'd have a toxicity value of 5,000 nanograms per kilogram per day. You would have an uncertainty factor of 1,000, and that would incorporate differences among species, differences between a LOEL and a NOEL, and differences in data availability. And you would be able to then calculate an answer of 50 nanograms per kilogram per day, and that is what we would call our acceptable daily intake. And with that, you can take the ADI, and you plug it into our enforcement standard. And because we know that the goal is to protect the young developing children, we use child stuff. So we would put the ADI in of 50 nanograms per liter, the body weight of a child of 10 kilograms that's specified in state statute, our relative source contribution, and divided by the amount of water that a child consumes a day, which then kicks out our enforcement standard of 500 nanograms per liter. And so as I mentioned before, DHS recommended individual standards for 12 of these PFAS in cycle 11. And rather than go through each individual one, these were the 12 individual standards that we recommended. And they ranged anywhere from 30 nanograms per liter all the way up to 450,000 nanograms per liter. So again, as we're kind of pointing out, not all of these PFAS showed the same health effects at the same concentrations. Therefore, you could have an argument that that's why some of these standards are higher, because they don't start to show effects until you get to higher concentrations. Now, as I kind of said, we only set 12 individual groundwater standards. But in cycle 10, DHS recommended a combined groundwater standard for both PFOA and PFOS as part of cycle 10. And they actually set recommended a combined standard of 20 nanograms per liter. Part of this review, part of cycle 11, we actually added 4 PFAS to this recommendation. We added NETFOSE, NETFOSA, or NETFOSE, NETFOSAA, NETFOSA, and FOSA to this recommendation. And we actually recommended these because they are precursors to PFOA and PFOS, both in the environment and in the body. So what I mean by that is these PFAS actually will break down over time, and eventually their end breakdown product will be PFOS or PFOA. So what DHS did then is then we recommended a combined enforcement standard of that 20 nanograms per liter for those 4 PFAS that I just mentioned to be combined with the original standard of PFOS and PFOA. And what is also just about as important to note of the fact of all the recommended groundwater standards that we did make, we did not recommend groundwater standards for 18 different PFAS of those 34 that the DNR had requested us to review. And a lot of the reasoning behind that is just there was no scientific information about the health impacts of these individual PFAS. So when you're thinking about the concept that there's 5,000, maybe more than 5,000 different PFAS that are out there, we really don't have an understanding of the health impacts of each of these individual PFAS that exists there, where there just isn't enough scientific information out there. And because of the fact that there is a lot of, each of these PFAS can act differently, we did not set any groundwater standards for 18 of those PFAS. And the last thing that I kind of just want to mention out there is that the state and the Department of Health Services is working to protect you from PFAS. And if you're interested in this and you want to learn a little bit more, I'd point you in these general directions. Especially the last one goes through in a lot more detail about each of the individual groundwater standards that we were able to create. And With that, I will kind of say thank you for listening, and I will open it up to questions for everybody.
Thank you, Gavin. I do have a quick question. Can you go back to a slide where you showed sort of a mathematical equation that came out to the result of 50, like 50 micrograms per liter? I just want to make sure that I was following it right.
Oh,
So on this one,
mm-hmm.
we're taking 5,000 and dividing it by 1,000.
Correct. Oh, I'm off by a zero here.
Yeah, I just want to make sure.
Yeah.
This is just this is just an illustration. This is
correct.
Not the actual calculations.
Yes, correct. Sorry, this
okay.
is a kind of a hypothetical version,
Yes,
but that would be 5. Yeah, none of these were actually made.
And you guys, everybody is, you're not the person doing all this work. There's a team, right? Do you want to describe that team a little bit?
Correct. Yeah. So there was a team of 5 or 6 of us that were all involved in making the groundwater standards. So I am not the only one that helped set all of these. We did have a whole team that was kind of working on it. That was really being led by Dr. Sarah Yang. So, yeah.
And a lot of them are essentially civil service, longtime DHS staff. Would that be a good way to characterize them?
Yes, exactly. So
these are not like the governor planted them in to make these standards. These are people who.
Correct. That is a great question. These are the groundwater toxicologists for the state that's been there for a while. These have been cycles that have been going on for years. As I mentioned, this is the 11th time that this has been asked. So, yeah.
And then a question did come from the audience about sort of applying this or thinking about, what you've described is very much using the literature, using scientific studies on toxicity, which we really hope, right? We're glad that these aren't necessarily carried out on humans.
Correct.
But then there's the real world. And so we have things like water in school systems, for example, where we think of like in let's say an elementary school, the average person consuming the water from the drinking fountain is going to be different than someone like me, who's a much larger human, and I have a different mass. And how do we then apply these in the sense of like, oh man, we want to make sure these kids are not getting unsafe drinking water? Can you walk us down a road of kind of where this goes next?
Awesome. So yeah, so that's a great question, and I'd be glad to kind of clarify it. So DHS actually, we set our groundwater standards to be the most protective for the most sensitive or vulnerable populations. So in this case, for the PFAS, we're actually setting it for the babies or infants. So these groundwater standards are meant to then protect the most vulnerable population of that life stage. And so by then setting them at that sensitivity level, it's supposed to be protective for all of us.
Sure. So then and then kind of where the rubber hits the road, like is it up to the DNR then to begin enforcing or setting those, like what I assume somewhere there's a list of standards that a school system's water must meet or exceed. Is that's a Department of Natural Resources responsibility, or is that fall back to DHS?
Correct. Okay. So yeah, so I'm not too familiar about the process after. So what I do know is that once DHS, we make our recommended groundwater standards, we then pass them back to the DNR, who then go through it's about a 3-year process to turn these groundwater standards into rule. And there's kind of an open public part where public comment can come in on all these rules. And it's a long, thorough process that it goes through before they actually become part of the rulemaking or become an actual rule. Yes.
And so in one way to almost paraphrase all that is that the DNR is not just able to pull arbitrary numbers out and say, we think the standard should be this, just because that's what we decided today. Yeah. It all has to fall back on both the science you're talking about with DHS, but also this process. Like they don't get to just willy-nilly change it.
Correct.
You mentioned this is the cycle 11. I don't know if I caught sort of when was cycle 1? How long have we actually been doing this type of review process?
So that's a good question. I can tell you cycle 3 was in 1985. And I just know that one off the top of my head. So it's sometime before then, at least. So this has been going on at least since 1985. I wish I could tell you when cycle 1 was, but
That's
unfortunately, I
fine.
just know cycle 3 was 1985, so at least then. But just to kind of reiterate, I think what's important to kind of note is that this is a process that is specified in state statute. So like we can't just go off the rails. We have to follow certain aspects that we do. And in particular, when we're talking about like the scientific literature out there, it has to meet, a very specific criteria for us to even be able to use scientific information that's out there. So it is a very laid out process that there is very little room for. There's no room for interpretation, right? It's a rules that are all done specifically laid out in state statute.
And I'm not sure if you have the answer to this question, but is this, when we're talking about a Wisconsin process, there's also an EPA at the federal level that's working to protect people's drinking water and groundwater. And my understanding is that Wisconsin sort of operates within those EPA boundaries, that we can be sort of more protective than the EPA. We cannot be less protective than the EPA. Would you say Wisconsin kind of fits well within, say, Michigan and Minnesota and Illinois? Are we trying to be, would you say our process is more protective? How do we fit in?
Yeah, so that's a really good question to kind of ask. So, particular for the EPA right now, there is really kind of a process for two different PFAS. That's the PFOA and PFOS. And that standard, we are for at Wisconsin level, we are safer, or we're being more protective for those as new information has um, been discovered. We're learning that maybe the EPA number wasn't protective enough. So Wisconsin, just like other states like Minnesota in particular, we're being a lot more protective. And I know that both Minnesota, Wisconsin, Michigan, we're all falling in the same kind of zone for those, for PFOA and PFOS. For other PFAS that are out there, Wisconsin, we will have, I believe it's either we will either have the most recommended groundwater standards, or maybe the second state. I can't remember exactly how many Hawaii is putting out there, but definitely we'll have recommended groundwater standards for the most or close to the most PFAS. And a lot of these PFAS recommendations all kind of fall similar state by state, as of course we're looking at the same scientific literature that is out there. And then part of the reason you're going to see some differences state to state is each of that equation that I showed that was specified in state statute, that's going to be different depending on which state you're going to.
Okay. And then I have one last sort of culminating question.
Yeah.
It seems like it's a no-brainer to say, boy, we better not be making more of these chemicals. But I also have a feeling that we are.
Mm-hmm.
Do you have just sort of a personal take on like where are we headed with respect to these specific chemicals that are so persistent and it's kind of challenging, right? Because they're also not easy to get out of the environment. Are we at a point where people could say, look, we're going to shift to a whole different production system, or what do you know about PFAS and PFOA?
Yeah, so that's a good kind of question. So in the U.S. in particular, PFOA and PFOS are banned from production. So we are no longer in the U.S. And I do want to say at least parts of the EU are also have banned it. And so what that really means is we're no longer putting PFOA and PFOS into products, let's say. Now, that's this from the US. So there's other countries that exist out there that still allow this. So if you're buying products from different countries, potentially you could still be adding or being exposed to those too. But particularly in the US, we no longer use them. That being said, we have switched to kind of some other PFAS in the same chemical or same family. Some important ones that are maybe a little bit well known now are that Gen X, or there's another Donna. So again, these are just acronyms for different PFAS that exist out there that are supposed to be um, more readily degraded in the environment, have less health impacts, and so the goal is, I think, in theory, we're moving to some less toxic versions of these PFAS. And yeah, I'll kind of stop rambling there, but
Sure.
yeah.
No, that's good. All right. Well, there's a lot to be involved in, and it sounds like there's still more steps in the process for people who are concerned about this to really plug into that DNR process and make sure they're alerted. I know there's ways you can go on the DNR webpage and subscribe to different alerts if you're interested in how those processes play out. So it looks like here, these are and you can also go online and just find more of the fact sheets. So encourage people to do that.
Yeah.
I want to thank you, Gavin, for joining us for Wisconsin Water Week, sharing what you've been working on. We look forward to seeing you again on Wednesday, it sounds like.
Yeah. Yeah. Thank you very much for this opportunity. It was really, really fun to talk about the groundwater standards.
All right. Thank you, Gavin.
Yep. Take care.
And if we stop the stream, it'll take a little while for it to clear out.